any of the work as it is in the book, I quickly want to show you something. If we have constant velocity, and if we have constant acceleration, what is the difference? Let's say our constant velocity is 2 meters per second, and let's say our constant acceleration is 3 meters per second squared. Now, first of all, the definition of velocity is a rate of change of displacement. Are you all with me? The definition of acceleration is a rate of change of velocity. This one, speed, is displacement divided by time. Acceleration is velocity over time. All right. So, if I say I am traveling at a constant velocity of 2 meters per second, it means in the first second I will travel a distance of 2 meters, which means my speed is 2 meters per second. In the second second, what distance will I travel? After 2 seconds, it would be 4 meters. But in the second second, I will travel 2 meters. So after 2 seconds, I will have traveled 4. My speed is still 2 meters per second. In the third second, what distance will I travel? Still 2 meters. In total, after 3 seconds, I will have traveled 6 meters. What is my speed? 2 meters per second. Are you with me? Now, when we are accelerating, in the first second, let's say I'm accelerating at 3 meters per second. So in the first second, I am going to travel 3 meters. My speed in that second is going to be 3 meters per second. I am accelerating at 3 meters per second. So, in the second second, I am now going to travel 3 meters further. I'm traveling 6 meters because I'm accelerating at 3 meters per second. So, after 2 seconds, I will have traveled a distance of 9 meters. But in the second second, what is my speed? 6 meters per second. If I subtract them, the difference is going to be 3 meters per second. I am accelerating at 3 meters per second. So in the third second, I must travel 3 meters further than in the previous. I'm going to travel 9 meters, which means in total, I will have traveled 18 meters. But in this third second, what would my speed be? 9 meters per second. Can you see the difference is constant? 3, because I am accelerating at 3 meters per second. Can you see the difference? Because one tends to become very confused. We have done constant velocity in the previous unit. In this unit, we must now look at acceleration. Can you remember the graphs? We had a displacement time graph for constant velocity. Looks like that. A velocity time graph for constant velocity looked like that. Now, the acceleration time graphs. The displacement time graph. Can you see? It goes 3, 6, 9. So the graph does not do that. The graph does that. It's an exponential graph. No. The displacement time graph. Well, if I have a velocity or speed time graph, what happens to my speed? It's going to increase. So it's going to look like that. And then the acceleration time graph. What is my acceleration? It is 3 meters per second. That would be the acceleration time graph. Does it make sense? The difference in the shape of these graphs in comparison to the shape of those graphs. That is why it differs, because this is constant velocity, that is constant acceleration. All right, now we can go and see what your notes say. Is that the first page? Let's start there. Unit 5, the heading is acceleration. When we start with a quantity, we need to know the definition. Definition of acceleration is rate of change. When you see those words, you must know we are dividing by time. Rate of change of velocities. Velocity, a scalar or a vector? It's a vector. So acceleration, is it a scalar or a vector? It's a vector. The direction for acceleration is positive or negative. A positive acceleration will mean it's going faster and faster and faster. A negative acceleration will mean it's going slower and slower and slower. When we had velocity, a positive velocity meant in one direction, and the negative velocity would be in the opposite direction. Okay. So, acceleration is a vector quantity. It can be positive or it can be negative. If it is positive, the object is going faster and faster. If it is negative, the object is going slower and slower, and the negative acceleration is known as deceleration or also retardation. A friction is a retarding force. It makes you go slower and slower. Okay, now we have got a velocity time graph there for the velocity time graph. Determine the acceleration for the following velocity time graphs. Now, when we calculate acceleration, the formula is change in velocity over change in time. The unit is a meter per second divided by a meter per second, which is a meter per second squared. We can also write this as meter times the second to the power minus 2. It means the same. All right, that is a comparable unit. Now, when we had a look at the graphs, we said we can work with two things of the graph. The one is the gradient of the graph, and the other thing was the area under the graph. Now, when we had a velocity time graph, we said the gradient gives us velocity divided by time, which will give us acceleration. So, what will the gradient of these lines give us? Acceleration. So I could have also said, determine the gradient of the line. How do we get the gradient of the line? Well, we need a change in y over a change in x. And please note, I could work with a very small one, but then my error reading is going to be bigger. Do you understand? So I take the biggest gradient possible, and I will work with, there's y1, and there's actually, this is y1, and that is y2, and we have x there, and x there. The gradient, this is going to be x2, and that is x1. The gradient is going to be change in y over change in x. What's the change in y? It's going to be y2 minus y1. y2 minus y1. And the x is x2 minus x1. All right. And if we divide a meter per second by a second, our unit is a meter per second squared, which is the unit for acceleration. So the gradient of a velocity time graph gives me acceleration. Now this one, the acceleration is positive, because here the y2 is bigger than y1 and x2 is bigger than x1. Now if you were asked to work out the gradient of this line, well, we can still use as big a part as possible. There I have a y reading, and there I have a y reading. That would be y1 and y2, and over here I have an x reading and an x reading. The gradient is still y2 minus y1 divided by x2 minus x1. But can you see this graph? The gradient increases from left to right. On this graph, the gradient decreases from left to right. So when the gradient increases from left to right, we have a positive acceleration. When the gradient decreases from left to right, we have a negative acceleration. All right. Yes. Change in y over change in x. When we start working with accelerating objects, we differentiate between an initial velocity, the one we start with, and a final velocity. All right? Now, when we work with it in a formula to prevent us from becoming confused, we work with initial velocity as a small letter u and final velocity as a v. So the change in velocity, remember the triangle means change in velocity, is final velocity minus initial velocity. If my final velocity is 2 meters per second and my initial velocity was 10 meters per second, if my final velocity is 2 meters per second and my initial is 10 meters per second, what is my change in velocity? It is final minus initial. It is v minus u, so it is 2 minus 10, it would be minus 8.
En over die T is dit over the top.
Yeah. Do you understand? Your velocity can be negative because it means it's going in the opposite direction to what it started out in. All right. Just here, repetition, the gradient of a line, change in y over change in x. If we have a velocity time graph, the gradient gives me acceleration.
ShopRite is your home of low prices this Christmas with unforgettable savings on everything you need. Stock up this festive season with great deals like 1.5 kilos of real good frozen mixed chicken portions, only $49.99, and 700 mils of all gold tomato sauce, just $26.99. Don't miss out on unforgettable savings at the home of low prices this Christmas. Only at ShopRite. Lower prices you can trust. Always.
Now, in the previous section, we had a look at the graphs, and we said then, just to recap very carefully, acceleration is a rate of change of velocity. All right. And then if we have a velocity time graph, all right, then we said the gradient of a velocity time graph will give me acceleration. All right. I don't want to say much more about that. I want to carry on at this point. We had a look at the terms initial velocity and final velocity, where speed is v, all right, velocity is v. We said we differentiate between a starting velocity and an ending velocity. And then the symbol we use for initial velocity is a u. All right. And then we had a look at the exercise 1, page 113 and 114. Just what I've said over there, the gradient of a velocity time graph will give me acceleration. Okay, now, if I climb up onto the roof and I jumped off the roof, why do I fall to the ground? Gravity pulls me down. Gravity is a force, and it makes me, if I jumped off a very high building, and if there was no air resistance, I would fall faster and faster and faster and faster. Okay, so acceleration due to gravity. If we drop an object from a height, we will find it will fall faster and faster. The reason is the Earth exerts a resulting force. All right? The pull of the Earth, the force of the Earth, makes the object accelerate. Now, when we talk about acceleration due to gravity, we talk about gravitational acceleration, and where acceleration is usually an A, when we work with gravitational acceleration, we use a G. Okay, people, lots of symbols that can confuse you. You have to go and learn them as we do them. All right. So the force that makes you accelerate towards the Earth is known as gravity. All right. If there was no gravity, would you have weight? No. All right. Your weight is a direct result of gravity. Yeah. All right. When we work with weight, we say your weight is a force, and we can calculate the force as mass times acceleration. We've been working with it. If you have a mass of 50 kilograms, what is your weight? Yes, we multiplied with 10, so you would get 500 Newton. We've actually been working with this formula where the acceleration is due to gravity. We just didn't tell you that in grade 8. All right. It was just easy to say to you, when you want to convert your mass to weight, you multiply with 10, because your weight is as a direct result of gravity. Okay. And the effect of gravity, it makes an object accelerate at 10 meters per second, which means any object that falls in the first second, it's going to fall through 10 meters. In the second second, it is going to fall 10 meters further. Do you follow? Okay, in the third second, it's going to fall 10 meters further than it did in the second. In other words, your speed is going to be 10 meters per second, then 20 meters per second, then 30 meters per second. Do you understand? Your speed will increase constantly, yes. So, we talk about something called free fall. When a body falls due to gravity, We say he is in a state of free fall. So when you are in a state of free fall, it implies there are no opposing forces, and the body will fall with constant acceleration. Now here on Earth, is that ever truly possible? No, because there is air friction. But if the object is small enough and the surface is smooth enough, over a short distance, we can accept that the influence of the friction is negligible. We ignore it. Okay. So when I refer to the term free fall, then you are falling due to gravity. Any opposing forces? No. So you will go faster and faster and faster and faster. All right. The acceleration due to gravity is the same for all masses. If there was no air friction, I took a feather and I took a lead sinker and I dropped them, what would happen? They would fall at the same rate. Does the earth have eyes to see? Can the earth see you and see the pencil and decide, oh, I'm going to have a stronger force on you than on the pencil? No. The earth exerts a force on all objects that will make that object accelerate at 10 meters per second squared. There are other factors that will influence the resulting force, depending on the size of the surface, the textures, etc. There is friction. Okay. Yes. There's a feather has been designed to have a very large surface, and it will bump into the air particles and have more friction than what a block of lead would. All right. So that complicates it. But when we talk about free fall, is there any friction? No. So any two objects, whether I have a big boulder like this and I have a tiny little rubber and we drop them from the same height, if there was no friction, they would hit the ground at the same time. The free fall part would be when he jumps out of the aeroplane, before he opens up his parachute. Then, well, he's not yet, the faster you go, the more friction becomes, and the bigger your surface area, the more. So, technically speaking, I don't think he's ever really in a state of perfect free fall. But they refer to that first part as free fall, because they are accelerating, going faster and faster. All right. People, acceleration due to gravity is the same for all masses the Earth can't see. Okay. Any object would be accelerated at a rate of 10 meters per second squared. People, if we go and have a look at it, on the Earth, the force of gravity will exert a force of 10 Newton for each kilogram of mass. It's just a ratio. If you have a mass of 1 kilogram, the weight is going to be 10 Newton. And if you have a mass of 50 kilogram, the weight is going to be 500 Newton. To make an object accelerate at 10 meters per second squared, if I have a small one, I need a smaller force. If I have a bigger one, I need or a heavier one, I need a greater force. Okay. So in terms of the matter, gravitational acceleration implies that any object will accelerate at 10 meters per second squared, which effectively means for every 1 kilogram of mass, a force of 10 Newton will be exerted on that object. Okay? We said force is m times g. So I said if your mass was 60 kilogram, gravitational acceleration is 10, your weight would be 600 Newton. All right? So, if you have a 600 Newton force, and we say that the acceleration is 10 meters per second squared, what is the mass? Just convert the formula. Yeah. Okay. Anything falling under the influence of gravity, when it starts falling, the speed is 0. In 1 second, it's going to fall through 10 meters. So in that first second, the speed is 10 meters per second. After 2 seconds, it is now going to fall 10 meters further. So it's going faster. It'll be falling at a rate of 20 meters per second. In the third second, yes, the speed is increasing, but the acceleration is change in velocity over change in time. So change in velocity over change in time, and the change every time is 10. And the time increment is 1. Do you understand? So the acceleration is constant, but what happens to the speed? It increases. Remember when we did the graphs, because I can see you mixed up, we said if my speed is 2 meters per second, and if my acceleration is 3 meters per second squared, then if I have a velocity time graph, speed time, it would look like that. A distance time graph would look like that. Are you with me? Okay. But when we are accelerating, now my speed time graph is going to look like that, because I'm going to go faster and faster and faster and faster. There. Okay. And we will find that the displacement time graph is going to be an exponential graph. Okay. The value of G, the value for gravitational acceleration, depends on the mass of the planet. On Earth, because the Earth has a specific mass, it has a specific force of attraction on you. If you went from here to the moon, we find that the mass of the moon is approximately 1/6 the mass of the Earth. Therefore, the gravity of the moon is approximately 1/6 of that of the Earth. In other words, if I have a mass of 60 kilograms on Earth, what would my weight be? 600 Newton. Now I fly up to the moon. Have I lost an arm and a leg? No, I still have a mass of 60 kilograms. But due to the mass of the moon being less than that of the Earth, my weight on the moon is going to be approximately 100 Newton. Right. Now we don't do Newton's laws of gravity. What it basically comes down to is any two objects, because they have mass, they have a force of attraction on each other. Okay? The smaller the mass, the smaller the force. But the bigger the mass, the bigger the force. So technically, the Earth has a force of attraction on me. But I also have a force of attraction on the Earth. But because my mass is relatively small in relation to that of the Earth, I can ignore my attractive force on the Earth. Do you understand? The moon has a smaller mass than that of the Earth. So the gravity of the moon is going to be less than that of the Earth. If I go to some unknown planet and there they have a strong